Good morning. Today we are doing lesson 14. Our objective is to construct parallel line segments and analyze relationships of the coordinate pairs. Problem 1, we're going to slide right triangle templates parallel to the axes along coordinate plane to create parallel line segments. So number 1 says to cut out a triangle. Well, I've already done that for you. I just can't pick it up here to show you. There we go. So this is the triangle we'll be using for today. It's triangle RST. So number 1 says, use the problem 1 coordinate plane on page 5. Plot point A and B at the following locations. So here is our coordinate, and we need to put A at point 2, 3. I'm going to zoom in so you can see a little bit better here. There we go. So A is going to be at point 2, 3. Coordinate 1, 2, up 3, 1, 2, 3. This is point A. And it says to plot B at 7, 5. So we're going to go over 7. Here's 5, 6, 7. Up 5. Well, that's already labeled for me, so I'm going up to 5. And here is point B. Then it says, draw line segment AB. So I'm just going to take the straight edge and I'm going to connect AB with a line. So there is line segment AB. Next says, describe the right triangle that you can see that has AB on its longest side. Well, if I were looking at this, and if I were to draw this triangle out, I could see here that it's got a height of 2 units, and the base is 1, 2, 3, 4, 5 units. And right here, I could see a right angle. So we're going to look here. I already wrote that out for us. So it's 2 units tall. The base is 5 units. 1 right triangle, and then it would also have 2 acute angles where A and B are. My line's a little off. It says find triangle RST that you cut out. Remember that the letters name the vertices of the angles. So this is the top, this is the side, this is right. So here is our triangle. How could you use triangle RST to draw a segment parallel to AB? So here is my AB. And here's my triangle, and if you look, it is perfectly straight with that top line there. So how could I make another one that's parallel to this? Well, in our last lesson, didn't we just slide it over? Or we could slide it down, or we could slide it down and over. So all I'm doing is moving it along the grid lines. I am not changing the angle. This is not how we do that. We just move it along the grid lines. So that's our answer for that. You can move it around on the grid line, up, down, left, or right. Number 6 says, place your triangle back where you first began drawing AB. Slide triangle RST to the right 1 full grid square. So here's my RST, and I am only sliding it right 1 grid square, just like that. And I'm going to go ahead and draw that line. It says, is side ST parallel to segment AB? Did those end up being parallel? Yes, they are. Number 8 says, what coordinate does the vertice of angle S touch now? So here, oops, showed you all the answers. Where angle S was, it wants to know what the new vertice is. So that goes here, and this is the top. So this is where S was. We're going to label it S, and this is where T was. So my vertice here, Miss Purdy, can you tell me what my X coordinate is?
For the S, it would be 1, 2, 3.
And my Y is?
It would also be 3.
So our coordinate for S is 3, 3. And what about T? So we're counting over. Here's 5, 6, 7, 8. Miss Purdy, do you agree?
Yes.
And we would go up to 5. So our T coordinate is 8, 5. Number 10 says, how does the X coordinate of the endpoints change when you slide 1 unit to the right? So I want to know what happened from A to S and B to T. When I move 1 unit right, well, the A coordinate was 2. What happened? What was our S coordinate, Miss Purdy?
That was 3.
So it got 1 what?
That one bigger.
And B was 7, and T is
8.
So it also got 1 bigger. They went from 2 to 3 and 7 to 8. Did the y coordinates of the endpoint change? So I want to know, did these ones move up at all? No, they did not. We only slid it to the right. We did not slide up. So no, the endpoints do not change. Number 12 says, as we move it to the right, the x-coordinates increase by 1. We're going to put it back to the original position. It says, explain how the x-coordinates would change if we slid it along the grid lines 2 units to the left. So here, I'm back at my original position, and if I slid it 2 units to the left, 1, 2, that would be my new location. I'm going to trace it. That way I don't have to hold it there. So this would be the new location. It says, explain how the x-coordinates changed as we moved 2 units to the left. So what happened to those x-coordinates, Miss Purdy, when we moved 2 units to the left?
Well, it became 2 less because it was 2, and now it's 0.
So this one was at 2, now it's at 0. This one was at 7, now it's at 5. The new coordinates would be 2 less. We're going to position our triangle back at the original location again, and now we're going to slide it up 2 units. So here is AB, and I'm sliding my triangle up 2 units. 1, 2. And the question is it still parallel? Hold on, let me trace, and I'm going to mark the ends. So is this line parallel to AB? What do you think, Miss Purdy?
Yes, I would say yes.
Miss Purdy said yes. How do we know? Well, yes it is, because we kept the base parallel when we moved it up. We did not change the way we laid our triangle on the grid. Oops. What coordinate does the vertice of S touch? So here's the new S. We want to know what the coordinates are. Miss Purdy, can you help me?
Yes, 1, 2.
Okay, 2x.
And then the y would be, looks like it's right on 5.
2, 5. And let's just go ahead and do this new one over here while we're at it. So this would be 7. And
the other one would also be 7.
7, 7. So we changed to 2, 5 and 7, 7. Explain how the y-coordinates changed when we slid the triangle along 2 units up. So what happened to all of our points there? They got 2 units bigger on which axis?
The y-axis.
It went from 3 to 5 and 5 to 7. It says, did the x-coordinates change? Well, no, we did not move to the right at all or to the left. All we did was move up. So as triangle RST slides 2 units up, up the y-axis, the y-coordinate is increased by 2. So we're going to continue analyzing those points. Now it says, slide the triangle 2 directions along the coordinate plane. So we're going to put it back where it was. And this time we're going to move it 2 different directions. So it says, slide your triangle 2 units to the right and 1 unit down. Explain how the vertices have changed. So we are moving 2 units to the right, 1, 2, and 1 unit down, 1. So this is my new line segment. I'm going to trace it so we can see it. Now we've got a whole bunch going on now. But the question is, how have they changed? Well, what happened to our x-coordinate, Miss Purdy?
Our x-coordinates both got 2 units bigger.
Our x-coordinate is 2 bigger, and what happened to our y?
Our y-coordinates both got 1 smaller.
Very good. Okay, so that's what we have written here. The x got bigger by 2, but the y went down 1. So we already traced it, and we're going to label the endpoints S and T. We are going to have a whole bunch of S and T's on here now. So the question for 3 is, remove your triangle are line segments AB and line segments ST parallel. How do you know? Well, here's AB, our original, and here's the new ST. And Miss Purdy, do those look parallel to you?
They do look parallel.
They look parallel to me too. And we know because they will never touch. All we did was slide our segment over and down. We did not change the way the angles sit on the grid lines. So here it says line segment AB and line segment ST are parallel because they are both parallel to the imaginary segment we found when we first slid the triangle down. Write the parallel statement. So a parallel statement is just stating which line segments are parallel, and I have that written for you. We show parallel with 2 parallel lines. So line segment AB is parallel to line segment ST. So we need to record the new coordinates of S and T. So here we have 1, 2, 3, 4, 1, 2. So S is 4, 2. And T, here's 5, 6, 7, 8, 9. And it is 4, 9, 4. Compare the coordinates of A to B and the coordinates of S and T. Explain why each x-coordinate in points S and T are 2 more than the coordinates in A and B. Well, they're 2 more because we moved it 2 to the right. When we move on our coordinate plane to the right, our x gets bigger. So, Miss Purdy, what would happen if I slid it to the left?
It would get smaller.
Oh, okay. Explain why the y-coordinate is 1 less. Well, we slid ours down. When we slid the triangle down, you guys can't see it. When we slid down, our y-coordinate gets smaller. Miss Purdy, what would happen if I slid my triangle up?
Well, the y-coordinate would then get bigger.
Okay. So we slid the triangle 1 unit down, so it got smaller. Don't forget to do your exit ticket.